So this is the crystal polarization sa synovial fluid. So in identification of the crystal, we use crystal polarization. Now the technique not in the crystal identification is called the compensated polarized light microscopy. So in a compensated polarized light microscopy, we use a red compensator that is placed in the microscope between the crystal and the analyzer. So as you can see here in the figure 1, muna ang setup. This is the setup of the compensated polarized light microscopy or the microscope. So as you can see, this is the eyepiece, the analyzer, the first order compensator filter, the objective lens, the crystals, ito yon. Tapos this is the stage, and then the polarizer and the light source. Now, ano kaya tong compensator filter? For the red compensator. Ang ginagawa ng compensator, it separates the light ray into slow-moving and fast-moving vibrations and produces a red background. So remember, our crystal is birefringent in nature. So meaning, in definition, birefringent materials are those materials that that has the ability to refract light. That has the ability to refract two lights, okay? So, two refracted lights yung product ni birefringence. Yung orientation naman, in an orientation of 90 degrees. So, meaning, yung isang refracted light is naka-orient 90 degrees from the other refracted light. So, to illustrate, I have draw here an example, okay? So, itong color blue na to is called the incident light or yung light mismo, okay? Sabi daw, yung incident light or yung light is naka-orient siya, meron siyang horizontal and vertical orientation. So, itong dot na to is represents the horizontal orientation of the light. Ito naman tong line, itong arrow, represents the vertical orientation of the light. Now, nangyayari, yung birefringent material, so for example, this is the birefringent material. Ito siya, si crystal. Okay? Ang nangyayari, pag si incident light tatama kay birefringent material, ginagawa niya is that it can refract two lights, okay? In different orientation. Tapos, yung isa is naka 90 degrees relative to the other refracted light. So, ito. So, na-separate siya into two. Okay? Ito, yung vertical orientation ng light. So, na-separate yung vertical orientation of light from the horizontal orientation of the light, which is naka 90 degrees relative to this other refracted light. Okay. So, other name din ni vertical orientation ng light is ito yung naka-parallel orientation, ito yung naka-perpendicular orientation. So, ito yon, di ba? Yung orientation ng light, naka-vertical and naka-horizontal. So, pag illustrate natin yan, ganito yung mangyayari. Yan. Ganyan dapat ang mukha niya. Okay. Ganito na ang mukha niya. Yan. Ito yung vertical, ito yung horizontal. Tapos, pag tatama daw ito sa crystal, is masaseparate yung vertical at it ang horizontal. Like tayo. Now, yung significance ng dalawang ito is makikita natin sa pag-separate ng slow-moving and fast-moving vibration ni compensator. Diba? Since kay birefringence, dalawa yung product, okay? Yung dalawang product na yun is masaseparate further into slow-moving or makakategorize further into slow-moving and fast-moving vibration. via the compensator. In the compensator, as I said, mag-separate siya sa light ray to slow moving and fast moving, and it also produces a red background. So as you can see here, a sample of a corticosteroid. The corticosteroid is also a birefringent material. So makita nyo, nagamit dito, so gumamit dito ng compensator. So ang red, so nagproduce siya ng red background. Okay? Tapos, dalawa yung product. So ganito, may yellow na crystal and may blue na crystal. Ito yung dalawang product. Hindi birefringent material. Tapos, furthermore, nag-categorize na naman siya ng slow moving and fast moving through compensator. So actually, these crystals are all corticosteroid. So walang difference diyan, walang ibang crystal, kundi corticosteroid lang. Pero bakit dalawang color? Bakit ay yellow, may color blue? So that is the responsible. Ang responsible diyan ay yung compensator. So usually, yung slow moving vibration is ito yung color yellow. Tapos yung fast moving is ito yung color blue. So, sa next na discussion, madiscuss na ko later on. So, the positive identification for the crystals is by using the first order red compensated polarized light. So, money siya. Okay. So, the beta-metasone acetate corticosteroid is being used as a control slide for the polarization properties of the MSU. It's because si corticosteroid kasi is just like the MSU. It is a birefringent, okay, and has a polarization property the same with the MSU. That's why naging control slide. So for the difference between MSU or the monosodium urate and the calcium pyrophosphate dihydrate is ito. Both MSU and CPPD crystals can polarize light. So meaning they are able to orient the light into two different orientation. Okay? That's why they are birefringent. So in their nature, based on their nature, they can polarize light into two different orientation. Okay? Ang isa is naka 90 degrees. But MSU is more highly birefringent and appears brighter against the dark background. So, to give an example of the polarization of light by the crystals, okay? So, meron akong picture dito. So, this is a calcite crystal. So, calcite crystals are also birefringent. The same with MSU and CPPD crystals. So, ang nangyayari dito, pag itapat si calcite crystal sa lapis daw, is nakakaroon ng birefringence. So, meaning, dalawang refraction of light. So, isa naka-parallel at ang isa naka-perpendicular. So, based dito sa ating discussion dito. Isa naka-vertical or parallel, ang isa naka-horizontal or naka-perpendicular. So, itong image nito is called the ordinary image or the vertical or naka-parallel na image. Parallel to the axis of the crystal. No, ito naman is called the extraordinary image or extraordinary light. So meaning this is perpendicular to the long axis of the calcite crystal. So yun yung difference or yun yung yung definition or illustration ng birefringence. So birefringence able to refract two lights, one is perpendicular and one is naka-parallel. So meaning 90 degrees sila. The differences in the linear structure of the molecules in MSU and CPPD crystals produces specific color by each crystal when it is aligned with the slow vibration or slow ray and can be used in identification of the crystals. So yun na yun. Ito yung sinasabi ko. Pag itapat daw siya, tapos naka-align siya sa slow vibration, magproduce siya ng specific color. And in this case, yellow and blue. And yung yellow and blue na yun can be used in identification of the crystal. So for the MSU crystals, si MSU crystal daw is a negative birefringent material. Why? It's because yung molecules ni MSU runs parallel to the long axis of the crystal. Meaning, nakaparallel siya. So meaning, dili siya against. If dili siya against, okay, when aligned with the slow vibration, pag i-align daw siya sa slow vibration, the slow light is not impeded. So, meaning, hindi nabablock yung slow light na galing kay compensator, okay? As much as the fast light. So, which runs against that. So, meaning, si slow light is able to pass through the crystal. So, meaning, nakakalusot si slow light. That's why, color yellow yung kalalabasan. So, meaning the slow ray from the compensator passes quickly with the grain. So, the color against the magenta background is color yellow. So, if ang crystal daw, if ang isang crystal is tinapat sa slow vibration, so meaning naka-align sa slow vibration, tapos yung color na kalabasan is color yellow, so meaning that is a negative birefringent na material. Sorry. So, remember that, okay? Again, pag ang isang crystal i-align daw sa slow vibration, tapos color yellow ang kalalabasan na color ng crystal, so meaning, the slow light is not impeded, so meaning hindi na block sa slow light, so slow light can quickly pass through the grain or the crystal. So, that is a negative birefringent material. So, ito na naman. If the compensator is rotated 90 degrees. So, ano mangyayari? The crystal now is perpendicular to the slow ray. Kasi, di-rotate man natin ang compensator, di ba? So, meaning, nag-change yung orientation ni crystal at naging perpendicular instead of parallel. So, it changes to the opposite color from yellow to color blue. Why? Bakit may changes? Because the slow ray from the compensator passes perpendicular to the grain of the crystal. This is because of the rotation ng compensator, ha? So, meaning na-change yung orientation ni crystal. So, from the original, di ba, nakaparallel siya sa long axis. Now, i-rotate na to, so meaning nag-against siya, naging perpendicular siya instead of parallel. So, meaning the slow ray now is being blocked, okay? The slow ray from the compensator travels against the grain and is slowed. So, meaning na-block si slow ray. And si fast light na lang ang nakakalusot. Okay? Fast light passes much quicker in this equation. That's why, ang nangyari is there is a color change from yellow to blue. So, meaning, pag ang slow ray ang nakakalusot, color yellow. Pero if fast ray ang nakakalusot, color blue. Okay? So, i-disregard yung rotation ni compensator, okay? So, if ang pag isang crystal is naka-align sa long axis or sa slow vibration, if ang crystal is naka-align sa slow vibration, tapos color yellow ang product niya na color, meaning the slow light is not impeded, is not blocked, so that is a negative birefringent material. However, if the compensator is rotated 90 degrees, mag-change siya from yellow to blue. It's because si slow ray is against na siya sa grain, and the slow ray is being blocked, and the fast light na lang ang nakakalusot. That's why it changes from yellow to blue. Okay, on the other hand, the CPPD crystal is a positive birefringent. Let's know why. It's because CPPD, the movement of molecules ni CPPD run perpendicular to the long axis. So, kabalikran siya ni MSU. Diba? Si MSU it runs parallel. Si CPPD, it runs perpendicular. So, ano mangyayari pag i-align siya sa slow vibration? So, when aligned with the slow vibration of the compensator, the velocity of the fast light passing through the crystal is much quicker. So, meaning, si fast light lang ang nakakalusot. Si slow light is na-imped or na-block. So, that's why the color against the magenta background is color blue. Okay? So, ganito. For positive birefringence, okay? So, isang crystal, inalign mo sa slow vibration, tapos color blue yung product niya na color, it's because the slow light is being black, tapos si fast light lang nakakalusot. Kato daw na crystal is considered as a positive birefringence. So, kabaliktaran siya ni negative birefringence. Okay? Kasi kay negative birefringence, pag i-align daw sa slow vibration, color yellow. Pero kay positive birefringence, pag i-align siya sa slow vibration, color blue. It's because yung fast light lang nakakalusot. So, color blue. Remember that, okay? So, karon, if the compensator is rotated 90 degrees, anong mangyayari? The crystal now is mali ito ha. This is parallel. So, pag i-rotate daw ang compensator, anong nangyayari? Si crystal now is parallel to the slow ray. So, meaning, there's a changes now to the opposite. It changes now to the opposite color. Bakit? The slow ray from the compensator passes parallel to the fast axis. So, diba, since si PPD molecules, diba, in the first place, the molecules run perpendicular to the long axis. That's why magko-color blue siya pag i-align sa slow vibration. However, pag i-rotate nimo siya, so mababaliktad. So, magiging parallel siya instead of perpendicular. So, pag magiging parallel siya, so meaning, yung slow ray daw is hindi na siya naging against. So, meaning, with the grain na siya. So, meaning, the slow ray from the compensator passes quickly with the grain. Meaning, si slow ray can easily pass through the crystal. That's why the color changes from blue to yellow. So, summary, ito yung nangyayari sa base sa illustration. Okay. So, letter A, this is the negative birefringence. Sa letter B, this is the positive birefringence. So, negative birefringence daw nangyayari. Imagine na, itong arrow na to is the movement of molecules. Okay? And this line is the orientation of the slow vibration or the slow ray. Kay negative birefringence daw, yung movement ng molecules is parallel to the slow ray. So, meaning, with the grain siya. Parallel siya. So, meaning, the slow ray is not impeded or hindi nabablock. That's why, color yellow ang kalalabasan. Now, if the compensator is being rotated 90 degrees, so meaning, na-change yung orientation ng crystal. So, movement ngayon ni crystal is against na sa slow ray. So, meaning, na-block yung slow ray, tapos yung fast ray na lang ang nakakalusot. So, ang kalalabasan is color blue. Gets? Okay? Again, sa negative birefringence, ang movement of molecules ni crystal is parallel to that of the slow vibration. So, si slow ray or the slow light can pass through the crystal na hindi siya nabablock, so that's why color yellow. Now, if it is being rotated, yung compensator is being rotated, ang orientation na naman ng molecules ni crystal is being changed. So, from parallel to perpendicular. So, naging against na siya sa slow vibration. So, if it is against the slow vibration, so meaning si slow ray is being impeded. So, na-block si slow ray. And si fast light na lang or fast ray na lang ang nakakalusot. So, that's why color blue siya. So, in a sense, pag si slow ray lang or si slow light lang makakalusot, si slow light ang makakalusot, color yellow. Pag si fast ray ang nakakalusot, hindi si slow ray, color blue. So, that is the negative birefringence. Ngayon, kay positive birefringence, sa simula't simula, yung molecules ni positive birefringence is perpendicular to the orientation of the slow ray. Okay, or to the long axis of the crystal. So, meaning, against siya sa slow ray. So, pag i-align mo siya sa slow ray, okay, pag i-align mo siya sa slow ray, is, ang mangyayari is nabablock yung slow light. So, si fast light na lang ang nakakalusot. So, ang mangyayari, color blue ang kalalabasan. So, pag i-rotate na naman ito, ang compensator to 90 degrees. So, may orientation change. So, from perpendicular relative to the long axis of the crystal, nagiging parallel. So, ganito. Parallel na siya sa slow ray. So, meaning, the slow light can easily pass through the crystal and it produces a yellow coloration. So, that is the negative birefringence. So, baliktad lang talaga sila. So, remember, pag negative birefringence, color yellow, ang pag i-align siya sa slow vibration, pag sa positive is color blue, pag i-align siya sa slow vibration. So, this is a summary of birefringent properties of MSU and CPPT in other crystals. So, for negative birefringent materials, ang crystals kay MSU, cholesterol, corticosteroid, calcium oxalate. So, all of these are negative birefringent. And CPPD, corticosteroids are both positive birefringent. So, the movement, yung differences, okay, comparison ng movement of molecules to the long axis of crystal kay negative birefringent, trans-parallel. Okay? Pag negative, parallel. Pag positive, perpendicular. Okay? Remember that. When aligned to slow vibration, anong nangyayari? The velocity of light sa negative birefringent of slow light is not impeded as much as fast light. It's because trans-parallel. So, meaning hindi nabablock yung slow light. That's why nakakalusot sa slow light. So, the color is yellow. Oh. On the other hand, sa positive birefringent is because it runs perpendicular, so meaning nabablock yung slow light. So, the velocity of the fast light is much quicker than the slow light. So, meaning nabablock si slow light, si fast light lang ang nakakalusot. That's why color blue ang color ng crystal. So, kung i-rotate na naman yung compensator 90 degrees, baliktad lang ang mangyayari. From yellow to blue for negative birefringent, sa positive birefringent is from blue to yellow. Kasi nga may orientation change. Okay, may orientation change.